Hi there, so this is us doing a wee video on the cosine rule, using it to calculate an angle. Hopefully you've had a wee look at the video on calculating the lengths of sides using the cosine rule, in which case you'll have come across the fact that we're using this thing here. So a squared equals b squared plus c squared minus 2bc cos a, on the basis that we are using our normal naming of angles and sides, small a, small b and small c and all that stuff. Okay, now you could technically use this to calculate the size of an angle by substituting everything that you know, and you'd be left with cos A as the unknown. In other words, you wouldn't have a number on the left hand side. You'd then have to rearrange the whole thing to then calculate A. So what we do, because it's something we do a lot, we rearrange it first and we just write down this as what looks like a second or a different formula, but it's the same formula rearranged. I'm just very quickly going to show you how that's done. You're changing the subject of the formula and all that kind of stuff. So if we've got cos A here, what I want to do is we could take this whole thing over to the other side, adding 2bc cos A to both sides, or doing the opposite operation, in which case we'd end up with a squared plus 2bc cos A on the left equals b squared plus c squared on the right. We want to then get rid of that a squared, which is positive. So on the other side it will appear as 2bc cos A is equal to b squared plus c squared minus a squared. And then in the end we want to rearrange it in terms of a. We've got to keep the cos in front of it. We can't escape that for just now. The 2bc is multiplying times cos A, so if I rewrite that, it's going to be cos A is equal to the right hand side, b squared plus c squared minus a squared all over 2 times b times c. That is the form of the cosine rule that we're going to use for our angles. Okay, so cos A is equal to b squared plus c squared minus a squared all over 2bc. Again, just like the finding the sides, we could rewrite that with different letters as long as we understand the pattern. So if I wanted to find angle C, for instance, I could write down cos capital C. You'll notice that on the right hand side the first two letters are the other letters other than the angle. So I'd have a squared plus b squared. I'd then be subtracting another letter squared, and it's the same letter. So again, the letter at the beginning of the formula and at the end of that top line should be the same. But of course one's capital, one's lowercase, so it will be side C squared on the top, divided by 2 times, remember it's the first two letters you wrote down on the right hand side, 2ab. And if you want to try it yourself for cos B, you could pause the video here and see if you can write it down first. Okay, so cos B is a squared plus c squared minus b squared, all over 2, first two letters I wrote down on the right hand side, 2ac. Okay, so first of all, make sure you write down the formula correctly, and then let's try and do this problem here. Calculate the size of angle ACB to one decimal place. So here we've got angle A and side A, angle B, side B, angle C and side C. We're trying to calculate the angle at C, so our formula is going to start cos capital C. So we're going to have a fraction here. On the right hand side we're going to write down the two letters that aren't C, which in this case are a squared and b squared. We're going to subtract from that the side that is C, divided by 2 times the first two letters I wrote down on the right hand side, AB. Once you've got the formula written out correctly, again it's just about substitution and calculation. So A is 9, B is 5, C is 7, and we've got 2 times a times b, which is 9 and 7. Okay, I would do this as 2 separate calculations this time around. There's too many ways in which a calculator can get the order of operations wrong. So I'm just going to go 9 squared plus 5 squared minus 7 squared. I'll press equals and write down that number 57 over 2 times 9 times 7. 2 times 9 times 7 is 126. And then I'll use my calculator to do 57 divided by 126 is 0.4523 and so on. So 0.452 I'll probably use. Okay, so in order to get the angle C, I need to do inverse cos. Unlike the sine rule, you're always going to get the correct angle. Now, we word of warning, if you haven't done a whole lot about trig graphs, sometimes this decimal here will be negative because the number here at the end will end up being bigger. So sometimes this value here that you're subtracting will be bigger than the sum of the first 2 numbers, and you'll get a negative numerator. That's fine. Your calculator will deal with that. Again, that's telling us that it's going to be an obtuse angle C, but your calculator will tell you that there only is one value of C that would work for that in the cos ratio. So what we want to do is do inverse cos, shift cos 0.452, and end up with 63.127. It says to 1 decimal place, 62.1. I'm rounding it, and of course I'm using capital C. It's not really proper terminology. The best answer then is angle ACB is equal to 63.1 degrees to 1 decimal place. There we go. Okay, that's us using the cosine rule to calculate an angle. Got one other example here, which is starting to get into the kind of story problems, context problems that most of your work will do. So here we've got an overhead light. It's hung above the middle of a 10-meter long stage. The distance from the light to the ends of the stage is 5.5 meters. What beam angle will allow the whole stage floor to be lit? So we've got 10 meters on the base of the triangle. The distance from the light to the ends of the stage means that that's 5.5 meters on either side. It's in the middle of the stage, so these are equal. It's an isosceles triangle. If in doubt, if you need to, draw a separate triangle here without all the wee extra bits. But effectively, what we need to do is add in some letters. So let's just go A, B, and C up here. And therefore small a, small b, and small c. What beam angle, in other words, it's asking for this angle here. What angle will allow the whole stage to be lit? Again, we're dealing angle C, so I'm going to use cos C is equal to a squared plus b squared minus c squared all over 2ab. I put in my numbers here, so a is 5.5 squared, b is also 5.5 squared, and c is 10 squared all over 2 times 5.5 times 5.5. Now, interesting, this is like I was talking about here. When we do this calculation, 5.5 squared plus 5.5 squared minus 10 squared, which is 100, we're going to get a negative number, negative 39.5, that's fine. And then we've got 2 times 5.5 times 5.5 on the bottom, and we get 60.5. As far as your calculator goes, we've got 39.5 divided by 60.5. We've got negative 0.6528, 0.65289, and so on. I'm going to use 0.653 cos C equals negative 0.653. And if you go ahead and put inverse or shift cos, put in your negative 0.653. Remember to use not the minus or subtraction button, but to use the negative sign somewhere on your calculator. If you do that, then for sure it gives you C equals 130.76.8 degrees. In other words, it is an obtuse angle. We don't have to think about there aren't two possible angles like in the sine rule. It's just good old read what your calculator tells you. Now C equals 130.8 is not the correct answer. What beam angle will allow this whole stage floor to be lit? We can actually write a beam angle of 130.8 degrees will allow the whole stage to be lit. Okay. So always try to finish the question based on what the wording of the question asks you, and when we're getting into the word problems, then that'll be a bit more of an issue. But for the moment, I'm just trying to make sure that you've got the basic idea of using the cosine rule for sides and now angles. So I hope that's helpful.